Let's look at this indices equation problem. So in this question, I'm told that 2 to the power of x is 2 to the power of n divided by cube root of 2. And remember, we always write cube root as to the power of a third. That's what it means. The root is 1 over whatever the root number is. And then 2 to the y equals root 2 to the power of 5. Now, if we look back, root 2 is the same as 2 to the power of a half, but we're taking that to the power of 5. So we're just going to multiply these indices through and get 2 to the y is 2 to the power of 5 over 2. So that's our equation for y. If we come back to x, we say 2 to the power of x is 2 to the power of n divided by 2 to the power of a third. So we're going to subtract these two, because when we divide powers, we subtract. So we get x, 2 to the power of x is 2 to the power of n minus a third. So that's the full power, which therefore means that x is n minus a third, because I'm saying this equals that. And then if we come back over here, where I've said 2 to the y is 2 to the power of 5 over 2, I can therefore deduce that this y equals this. So I can say y is 5 over 2. And we're also told in the question that x plus y equals 8. So I can rewrite x is n minus a third and y is 5 over 2. I can do that as x plus y is 8. So therefore x, being this, is n minus a third plus 5 over 2 equals 8. And then I'm just going to turn these into fractions which I can add or subtract. In this case, 2 over 6 and 15 over 6. So I'm doing minus 2 over 6 plus 15 over 6. And if I subtract these equations, I get 13 over 6. And then I've just turned the 8 into a fraction as well, so I can subtract. n plus 13 over 6 is 48 over 6. And if we subtract this fraction, we get n is 35 over 6. So our final answer is 35 over 6. As a student myself, I used to struggle with indices, and it was only through practice and repetition and doing hard, challenging questions like this that I was able to really understand the laws of indices and apply them to exam questions. And this is exactly what I cover in my Easter masterclass, so sign up today.